a Dyson Sphere, has become one of the most iconic concepts of all the related Dyson theoretical structures. It proposes to siphon energy from a star. Physicist Freeman Dyson originally proposed the concept of a Dyson ring and Dyson Swarm back in 1960. But science fiction has since expanded it into a massive, exaggerated concept associated with the rise of a Type II Kardashev civilization.
Unfortunately, I used the word in my paper in Science, artificial biosphere, to describe these possible alien activities, biosphere just being an inhabited region. And I called it an artificial biosphere as being something that would radiate in the infrared band. And the science fiction writers got hold of this phrase and imagined it then to be a spherical, rigid object.
Is it even remotely possible to build a megastructure around a star, to harness its immense and endless energy and elevate the human race into a true interplanetary power? That's the seductive promise of a Dyson Sphere. Ironically, Freeman Dyson himself disliked the term and was not happy that the word sphere was associated with his name.
And the science fiction writers got hold of this phrase and imagined it then to be a spherical, rigid object. And the aliens would be living on some kind of artificial shell, a rigid structure surrounding a star, which wasn't exactly what I had in mind. But in any case, that's become then a favorite object of science fiction writers. They call it the Dyson Sphere, which was a name I don't altogether approve of. But anyway, I'm stuck with it. But the idea was a good one.
He never proposed a solid shell around a star and viewed the sci-fi interpretation as wildly misleading. Brutal realities are mostly glossed over in the belief that some kind of magical technology will solve the massive physical and technology barriers. We can start with the sun's radiation. It's so intense that it would shred every cell in your body instantly. The sun's radiation increases with the inverse square law. Getting 3 times closer results in 9 times the energy, hitting every square meter. A structure that orbits closer than Mercury, which is where most Dyson Sphere concepts place it, would have to survive temperatures well beyond 2000 degrees Celsius. No known material, not tungsten, not carbon composites, could survive such sustained exposure. Even if you invented a miracle material that could resist melting, it would be bombarded by relentless streams of high-energy particles, UV radiation, and apocalyptic bursts like solar flares and coronal mass ejections. How do proponents of the Dyson Sphere concept propose to control something like this? A massive solar flare. There is no shielding that could withstand this enormous release of heat and energy. Even if you did discover some kind of magical material, the quantities you would need are incomprehensible. For perspective, this is the size of the Earth compared to the Sun. Our Sun comprises 99.86% of all matter in our solar system. The next major problem you need to overcome is the Sun's immense gravity. It would introduce catastrophic instability. A solid shell, ring, or arm structure would have to remain 100% perfectly balanced in all directions in a scale that is nearly inconceivable. Even the tiniest micro-tilt, wobble, or drift would create ungodly torque and stress created by the insane gravity of the Sun. It would shred the entire structure in seconds. You're not just fighting thermal damage, you're fighting orbital mechanics. Any misalignment would trigger a cascade of shearing forces and orbital decay, crushing the entire structure or shooting it off into space. The Sun's gravity is 28 times stronger than that of Earth's, making a 200-pound man nearly 3 tons if they stood on the surface of the Sun. Some have proposed counter-rotating rings or magnetic stabilization as potential solutions, but the sheer scale of such a system makes the idea laughably absurd. A single ring, half the distance of Mercury's orbit, would span tens of millions of kilometers. The mass of material that would be needed is in the hundreds of quadrillions of tons, orders of magnitude beyond what humanity has ever or could ever build. Dismantle Mercury? Sure, it's rich in metals, but mining it, refining the materials, lifting them into orbit, and assembling them into balanced megastructures is not just a logistical nightmare, it's a physical impossibility. To construct even a fraction of a Dyson Sphere, you'd need to disassemble entire planets for their resources. You'd need trillions of coordinated launches, or nanobot swarms that self-replicate in solar orbit. Neither of those things exist, and if they ever do, they would still be no match for the sun's immense power. Even if you dismantle every planet in our solar system, every asteroid and meteor, the amount of material you would have wouldn't even come close to what you would need. That's assuming that every pound of every object that you dismantle is even usable. One of the biggest engineering challenges you would face is thermal rejection. How do you dissipate the overwhelming amount of heat before it melts everything? Every surface facing the star would absorb immense energy. That energy has to go somewhere. In space, there's nothing around to carry away the heat, so the only method to get rid of it is to slowly radiate it out into the void of space. But that process is extremely inefficient and requires a huge surface area because of the sheer lack of particles. If the heat isn't managed perfectly, it will build up very fast and cause the entire structure to overheat, melt, and collapse in a matter of seconds. The proposed rotating arm idea is even worse, and perhaps the most laughable of them all. These concepts imagine giant mechanical tethers that swing around a star, collecting and flinging energy to distant receivers. But to remain stable, these structures would have to spin at blistering speeds. At such velocities, stress on the materials becomes extreme. The centrifugal forces would rip the structure apart long before it ever completed even a single rotation, making the entire concept not just impractical, but borderline absurd. Even a single micrometeoroid strike would cause catastrophic failure. If you stop maintaining the system, stop actively managing orbital drift, thermal strain and alignment, or simply make a single error, the whole sphere will be destroyed. The sun will not cooperate. It's not a passive object. It's a gargantuan, unstable fusion reactor that becomes more powerful the closer you get. To think that humanity can develop the know-how to tame the sun's godlike power is delusional. Trying to build anything in a solar orbit that close to a star, in one of the most hostile construction zones in the universe, is wishful thinking at best. The cost alone would be incalculable. You'd need unlimited energy, labor, and materials, none of which are available. Stars are not generators waiting to be plugged into. They are violent and chaotic, with thermal and gravitational power that wasn't designed to be harnessed and ridden like a horse. The dream of taming a star with mere technology belongs firmly in the realm of science fiction.